Welcome to this preview video of assignment 4 in text processing and analysis. In this assignment, you need to download a zip file from the CMS called mini core new zip, which has 1,600 text files from the corpus of online registers of English, which was made by Mark Davies, who used to work in our department. And so there are 200 files from each of the following 8 registers. HI deals with how to or instructional. Text ID deals with interactive discussion. IN, informational coming from Wikipedia. IP, informational persuasion. ILY, song lyrics. NA, news reports. OP, opinion blogs. And SP, interview transcripts. Okay, so 200 files from each of those 8 registers. A register is just a variety of language. Okay, the file names are long. You can ignore everything except the first 2-letter code after the 1+. Let me just show you what I'm talking about. So here's a zip file. I unzipped it. After you download it, you unzip it and you get a directory with 1,600 items in there. I'll just open up the first one here just to show you that. Well, let me just look at the file name itself. They're really long. You can see how long they are. But what I want to point out here is that everything, you can ignore everything except the 2-digit or the 2-character, code there after the first 1+. Okay, so the 3rd and 4th characters in the file name identify the register that the file belongs to. So the first 200 in here are from HI. Now we have ID. You can see ID there. Now, if we jump down, we get into IN, IP, etc. LY, NA. Okay, so you can just rely on the 3rd and 4th characters of the file name identifying the register that it belongs to. So the instructions are for this assignment, you should select 3 linguistic features that you think will vary across the registers. All right, once again, we have song lyrics versus informational, kind of dry Wikipedia, how-to stuff, news. So just kind of think through like what linguistic features, what parts of language or what, aspects of language might vary as far as their frequency of use across these 8 registers, or at least a handful of them. Some of them. Okay, and then you write a Python program that uses regular expressions to find those features within the mini core corpus. The program should ignore the header in each file. Let me show you that file again here. So the first 6 lines here are header. The first 6 lines with actual text in them are what's called a header, which identifies the source where it came from. And so you should not use those in the frequency counts. I think the easiest way to deal with that is to use the re.sub function to search for a regex that matches an opening angle bracket and anything in between that and a closing angle bracket and replaces it with nothing. That is, it deletes it. Okay, that's probably the easiest way. And if you do that, if you use the re.sub to do that, then it will also get rid of these angle bracket H, angle bracket tags, and the P tags between angle brackets there, which you don't actually want either. You don't really want those in your frequency counts. Okay, so that's what I'd recommend for getting rid of the header. You'll likely have to deal with a character encoding other than UTF-8. Well, I'll tell you right now, CP 437 would be a good one to use as you're reading in these files. That'll work. There's another 1 or 2 that would work. Yeah, for some reason, they're not UTF-8. So, but CP 437 is an encoding that would work well with these files. Then the program should calculate normalized rates of occurrence per 1,000 words for each linguistic feature of the 3 that you choose. Next, the program should write the normalized occurrences to a CSV file so that there is a register column, which contains the 2-letter code for the register, right? You extract that out, the letter code out of the file name, right? and then a column for each of the 3 linguistic features. So you have 4 columns total. When imported into a spreadsheet software like Microsoft Excel, your CSV files should have 8 rows, right? 9 if you include column headers, and it looks something like this, right? Column 1 is the register, so HI, ID, IN, LY, and the others, right? And then column 2 would be the first linguistic feature that you wanted to look at, and you get a normalized count per 1,000 words in this register for that feature. And then the third column is linguistic feature 2 with its normalized count per 1,000 words in that register, etc. And then the third one there. So write a brief report in a docx file that discusses each feature, your hypothesis on how it might vary across registers, and the results, and whether your hypothesis for each linguistic feature was confirmed or not. Also take a small sample of the corpus, like a file or 2, probably just 1 file, to measure the precision and recall of your regular expressions and report those accuracy measurements. Okay, you turn it to the CMS zip file with your PY program in a PY file, your Python program in a PY file. You report in prose in a docx file, and then a CSV file that your program produces. So 3 files get zipped up into 1 zip file. You turn that in. Okay. Here's some tips down here. Okay. You may not need this. You probably wouldn't need this the way I'm going to suggest you do it here in a second. You wouldn't need to worry about getting the mean, but there are many ways to solve a coding problem. And this is particularly the case here. The way I'll show you, I think, is just kind of a pretty straightforward way. Probably not the most efficient way on the computer, but probably the easiest conceptually for us humans to think through the problem. If you can't, you can choose any linguistic features that you want. However, if you get stuck, here are some features that you can consider counting. Pronouns, like all pronouns, or just first person pronouns like I, me, mine, or my, or second person pronouns, whatever, any type of pronoun. You decide what you want to search for. Proper nouns in English start with capital letters, and so you could use that in a regex to try and find capitalized letters, or words that begin with a capital letter that don't have any, that have lowercase after that first capital letter, but that word is not at the beginning of a sentence. Or you could use a regex to try and find that. Past tense, if you're assuming that past tense ends in ed, words end in ed. Modals, contractions, punctuation, use of quotation marks, or others, anything. It's really up to you. Just be creative on what you think would vary across these 8 registers. And so the skills you'll need here, regexes again, right? We've seen regexes quite a bit. We'll see it a lot. We looked at regexes in lesson 3.1. You'll need to measure accuracy, precision, and recall. So if you need to review lesson 3.2 about measuring accuracy, you should do so, lesson 3.2. You'll need to string slice to get the 3rd and 4th characters out of each file name as you're going through the files. And so we looked at string slicing in lesson 2.3. You'll need to read in each file, right? So that we looked at file input and output in lesson 5.1, if you need to review that lesson. And we looked at normalizing counts to a base number in lesson 5.3. So that's highly important in this assignment, right? I asked you to do that, to normalize to a base of 1,000 words. And then character encoding, we looked at in lesson 6.1, but like I said, I'll just tell you right now, if you use CP 437, that will that'll be a good encoding to use for these files. Okay, so this is just a little bit of like pseudocode on how I would approach this, kind of the logic. If you can't think of the way to do it, then this might be helpful. If there are many other ways to do this, if you like to just do it some other way, that's totally fine. But if you're not even trying to approach this at all, this logic should do the job. First, you get the file names, right? You need to import OS and change directories into the directory after you unzip it. Get the file names. Make sure they have txt at the end. And then you open a connection to an out file, the CSV file that you'll write to. And then you loop over the 8 registers. I would put the 8 registers in a list. So these codes, I would put HI as one element, ID, each of these 8 2-character codes in a list. And then I would loop over that list in a for loop. And then I would create some counters, 4 counters. I would have a total word counter for the register, and a total or a counter for feature 1, linguistic feature 1, another one for linguistic feature 2, and another one for linguistic feature 3. So 4 counters total per register that you're going to reuse as you're going over the registers. And then at that point, I would loop over the 1600 files. And if the current file belongs to the current register, right? So you're going to have to string slice into the file name and look at the 3rd and 4th characters and see if those 2 characters are what you're currently looking at when you're looping over the 8 registers. If that is the case, then we want to disregard the header. That is, get rid of it before we do any counting. So once again, I would use the re.sub function to search for a regex that matches an opening angle bracket and anything, and then a closing angle bracket. And make sure you're doing lazy, non-greedy matching on that. Again, if you need to review lesson 3.1 on regexes, I would do that. So you search for that regex and you replace it with nothing. That is, you delete it. You split up into words, split up the current file into words, get the number of words in it, and add to the counter for the total number of words in the current register. And then look for 3 regexes for each of the linguistic features that you want, and add the number of linguistic features to their respective counters. Okay, once you've gone through all the the 1600 files, right? So the indentation will be right there. Once we're done with all the 1600 files, then but we're still within the current register. Then you normalize the counts of the 3 linguistic features to 1,000 words, right? So you take the number of linguistic feature 1, divide it by the total number of words in the register, and times it by 1,000. Once again, lesson 5.3 is where I present how to normalize counts. And then you write out the counts out to the CSV file. And then that will cause you to go, when that's all done, you would go to the next register on this for loop. Okay, so that's just meta code. There's kind of pseudocode on how I'd approach this, the logic I would use to approach this problem. There are many other ways. If you think if you have some other way to do it, you totally can use another way. But if you don't know what to do, if you're just kind of clueless on how to even approach this would get the job done. Okay, so, and as always, I'll be using the rubric attached to the assignment down here at the bottom, the same weekly assignment rubric right there. 6 points come from task completion, right? Does the script accomplish the task without airing out and without the human rater having to change much or anything other than pathways to the directory with the files, right? You have to interpret, and you have to submit some files. So all of this applies here. So 6 out of 10 points come from task completion and turning what you're asked to turn in. And then 2 points come from conciseness of code, making it reasonably concise using a for loop, for example, or if you want to use a function to not repeat yourself, that'll be fine. But a for loop would work just fine here too. And then comments for human readers. You need to leave some comments for the human readers reading your code. Okay. So as always, I am super happy to help. So don't hesitate to drop into my office hours or the office hours of the TA. Best of luck. See you next time.